Here are solutions to homework set number 9 for ECE 376. This homework set looks at timer interrupts, timer 0, 1, 2, and 3. Now the first problem asks you to measure time 200 nanoseconds, which is just pretty darn impressive. The first one is measure the time of your LCD out routines. So here I'm going to do LCD out, and what you do in the code, and bring that up, is you record the time before what you're trying to do, like the LCD out, do the operation, record the time at the end, then display the difference in time. So if I do that with the LCD out, the time I got was 6.2007 milliseconds. Okay, that's basically how long the actual LCD routine takes. Another one, suppose I did a combination lock. I want to hit the buttons 0, 7, 3, 1, 2, 0 to open the door. How long does that take? Well, what I can do is write a program. Here's my while loop. I'm going to wait until I hit RB0, that's the start of the combination, record that time, wait until I hit 7, then 3, then 1, then 2, then 0. When I'm done, what was the time difference? So trying that, let's see, let's go 0, 7, hold on, I forgot the combination. Okay, trying that again. So 0, 7, 3, 1, 2, 0. That took 51.66 seconds. Let's try that again. 0, 7, 3, 1, 2, 0. 0, 7, 3, 1, 2, 0. 9.09. Trying again. 0, 7, 3, 1, 2, 0. Okay, that was better. 2.54344476 seconds. Again, just a completely insane number of decimal places. Part C. How long does it take you to hit buttons 0, 1, 2, 3 times? Well, to determine that, again, I'm going to wait until I hit RB0, then 1, then 2, repeat 3 times. As soon as I release, then record the time difference, the time at the end, the time beginning. So let's try it. 0, 1, 2. So I go 0, 1, 2, 0, 1, 2, 0, 1, 2. That was 2.3190217 seconds. Let's try it again. 0, 1, 2, 0, 1, 1, 2, 0, 1, 2. 2.80193868 seconds. So that's timer 0. With timer 0, you can measure time insanely accurately. And that's common with computers. Computers can measure voltage, they can measure time. Time is much more accurate. If you can convert a measurement to time, you can measure it insanely accurately. Problem 2. Let's build a 4-key piano. This one plays chords. So when I hit RB0, or hit a button, it's going to play 4 notes at the same time. On button C0, I want to play 440.6 Hertz. On C1, play 494.3, C2, C3. The trick to do that is I need to figure out how many clocks between interrupts. And then for timer 0, 1, and 3, that's just the time lag between, or the time until the next interrupt. For timer 2, that's the oddball. I've got to come up with A times B times C that's close to 95.55. This combination gets you close. The code then, in the interrupt service routine, this is set up so it always plays. If I do an if RB0, then it only plays when I hit the button. Set up timer 0. This 40 right here is kind of a ballpark guess. How many clocks does it take to trigger the interrupt? Timer 1, timer 3, timer 2, I don't have to do that. That's your A times B times C. So there's your interrupt service routine. Again, I'm playing 4 different notes. The interrupts do not affect each other. Trying it. So here I took my file in MPLAB and just changed the one I'm compiling to chord. This is what chord looks like. I define the notes. I play each different frequency. These numbers I adjusted slightly. We'll talk about that in just a sec. The main routine turns on timer 0, timer 1, timer 2, timer 3, and then really doesn't do anything. compile, that would be F10 build, then download, hit reset, download my program, when the light stops blinking, the code is running. And here's the program running. You've got all 4 lights turning on. Those are your square waves. If I connect a speaker to RC0, there's the first note, second note, third. If I play them all at the same time, I'm able to play 4 notes simultaneously. So that's kind of where the interrupts, you can run multiple interrupts at the same time. They really don't interact. So here's the results. If I measure the frequency, that's the frequency that I measured. This is off a little bit. The reason being is the way I do the interrupts. I first handle timer 0, then timer 1, then timer 2, then timer 3. So likewise, the number of clocks it takes to get to this line of code increases as I get further down in the subroutine. So if I just make that 40, the first one, the frequency is a little bit off. I am short 15 clocks, short 8 clocks, short 1.45 clocks. And timer 2 does a different way of doing it. So a more accurate way to come up with the frequencies is if I change this 40, as I go further down, I need to modify how much delay it takes to get to that line of code. So it's actually better if I do 25, 32, 41. If I do it this way, the frequency is almost dead on. So that's the problem with timer 0 interrupts, timer 0, 1, 2. If I implement frequencies this way, I've got this little fudge factor that accounts for how many clocks it takes to get to this line of code to trigger the interrupt. Next week when we do timer 1 to capture, timer 1 compare, I can get the frequency dead on without having to do that. But anyway, so I can generate 4 different notes using 4 different interrupts. Next problem, I want to play Super Mario Brothers theme. So here's what it sounds like. To change it, I'm going to change the file I include to Mario. Close these all down. Here's the code. We'll talk about that in just a sec. Build. Still building. So that was 3144 bytes, 1,572 lines of assembly. Download the code, go to the Pick Flash tool, download it. I'm now playing Super Mario Brothers theme. Okay, so how do I do that? Well, here I'm going to use a couple different interrupts. I'm going to use timer 1 to set the frequency of the note. I'm going to use timer 2 to set the duration. And likewise, I don't have 2 interrupts working together. For the flowchart, I'm going to have the main routine. A couple ways of doing this. This is one way. I'm going to play the tune, wait a second, then repeat. In the background, I've got interrupts running. Timer 2 measures time in milliseconds. I've got a global variable called delay. I'll decrement to 0, stop at 0. That's used to help with the timing. Then timer 0. This is outputting the frequency. If there's a global variable called play, that's 0, don't do anything. If I am playing a note, I'll then look at delay. If delay is bigger than 50, meaning 50 milliseconds, I'll toggle RC0, otherwise clear RC0. So what happens is, if I'm at 200, I'll play a note for 150 and go silent. The total time then is 200 milliseconds. That last 50 milliseconds is so you can hear the difference between the notes. Da 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 That's a flowchart. The code, there's a couple different parts. I've got, these are compiler directives. That just makes the code easier to understand. This is the same thing as that note. That's where you calculate 10 million divided by 2 divided by hertz. That's the number of clocks between interrupts for the different notes. Timer 0. I'm going to play a given note, bias by 40, trying to get the frequency more accurate. That's how many clocks it takes to trigger the interrupt. If I'm playing a note and delay is bigger than 50, toggle RC0, otherwise clear RC0. If I'm not playing a note, clear RC0, acknowledge the interrupt. Timer 2. I toggle RC1 just so I can verify the timing on timer 2. Decrement to 0, stop at 0. For convenience, I wrote a subroutine called play note. If I do something like play E4 for 200 milliseconds, it's going to sit there and take N. If it's not 0, I'll play that note, set that frequency, set the delay, and wait until the note's done. If I want to have a quiet time, I'll set N equals 0. Then I'll turn off the frequency, set the delay, and wait. Now using play note, that subroutine, the main routine looks like this. I turn on timer 0, turn on timer 2. Then I'm going to play E4 for 200 milliseconds, E4 for 200 milliseconds, E4 for 400 milliseconds, pause, C4, E4, G4. There's my music routine. And again, here's what it sounds like. So you kind of see the music on here. That's one use of subroutines. It cleans up the main routine. For validation, what I did is change the program. Write a little short test routine, play the notes for 3 seconds, then I can use my frequency counter and check what are the frequencies of E4, C4, G4. So that's what I expected, that's what I actually got. The duration of the note should be set by timer 2. To check, that's kind of why back here on timer 2, where was timer 2? There. I'm toggling RC1. That way I can check the frequency in RC1. If it's 500 hertz, then timer 2 is running every millisecond. I measured it at 500.7 hertz, saying it's basically running every millisecond. The timing should be correct. Then the demo. It's where YouTube videos are good. So you can build yourself a music box. That's homework set number 9 for 376.